So now this questions says to that in order to improve the performance of the system, they basically added a feedback loop, as you can see here. Then we want us to find the value of k and the new damping. We want us to find the value of k so that the damping ratio of the new system is still 0.4. Then compare overshoot, rise time, peak time, and settling time, and the nominal value of the systems. So let's start. The first thing we need to do is we need to obtain their transfer functions of both systems. So for this one, this is a unity negative feedback, which we'll use this formula for it. So in this case, g of s is in this case is 20 over s plus 1 over 1 plus 20 s plus 1. So now to just make our life easier, we multiply the numerator and the denominator times s plus 1. This will cancel out this cancel out this will multiply 1 to leave itself there. So it's because of 20 over s plus 1 plus 20. And you can expand this. Now this is a typical form for a second order damped system. So this will be s squared plus 2 zeta wn s plus wn square. So in this case, wn square is equals to 20, which means wn will be equals to 20, which is equals to 4.472. We are solving this because we need this for settling time, rise time, and time constant. So this will be to find zeta, that's the damping ratio in this case, to be s equals to, because that's the center value here, s equals to 2 zeta wn s. This is also the center value here. They're in the same form. So s cancel s. We know what wn in this case is. So it's going to be divided by 2 wn divided by 2 wn, which will be equals to 1 over what's 2 times 4.472. So that will be 1 over 2 times 2 times 472, which is equals to zeta equals to 0.112. That will be the answer for this first figure. Now for the second figure, we need to obtain its transfer equation. So in this case, first we'll do the inner feedback. So that is a negative feedback. The negative feedback, the formula is g of s 1 plus g of s h of s, right? So in this case, g of s is 20 s plus 1, right? All over 1 plus 20 s plus 1 times k. We multiply the numerator, we can just put the k here to confuse us less. Multiply the numerator and denominator by s plus 1. This will cancel out this will cancel out this, and this multiply inside here to leave itself. So it will not be equals to, so it will be equals to 20 over s plus 1 plus 20k. That's it. So now we can just open the bracket. That'll be s plus 1 plus 20k. Now this is in the typical form of remember. So in this case, this will be wn square is equals to 20, which is equals to. So now that we resolve this, once we resolve this, you notice that this is in series with 1 over s here. So when two blocks are in series, simply just multiply them. So this will simply become 20 over s square plus s plus 20k s. And then you notice that once we're done with this, once there's a full block here, which is now this, it now has a feedback system, a negative feedback system, a unity negative feedback system. And remember the formula, so it should be 20 over s plus 20ks all over 1 1 plus 20 over s squared plus s plus 20ks. Multiply both sides by the denominator, it's cancel here, leaving you with only here. So it will be 20 all over s squared plus s plus 20k s plus 20. We can factorize this. So that will give us 20 over, we call it s squared 1 plus 20k. Factorize our s because that's a common factor. 20. And remember, this now takes the same form. Here and here is now the same. It'll be wn squared is equals to 20. That means wn is equals to the root of 20, which is 4.472. And for the center part is equals to, remember, 2 zeta wn. You can include the s, but the s will cancel out, you already know. Now remember from the equation, it says determine the value of k so that the damping ratio of the new system is 0.4. So in this case, we can equate zeta to be 0.4. We know Wn, so it's going to be 1 plus 20. Sorry, let me write it. It's going to be 1 plus 20k equals to 2 times 0.4 times 4.472. You can bring everything to this side. This will be this minus 1, which is equals to 20k is equals to 2.578. K would then be equals to 0.129. So we have found the value of k. And so we have gotten these values. Now we can calculate first overshoot. So we're calculating for percentage overshoot, which you can just write simply as MP. So the formula is E raised to minus zeta pi all over 1 minus zeta square times 100%. So for the first figure, that's figure 1, is going to be what? E raised to power minus 0.112, right? Pi over 1 minus 0.112 square times 100%. That'll be equals to 70.2%. For the second one, just put into your calculator, you're going to get 25.4%. Now for the second thing, which is the rise time. The rise time calculation is calculated as TR is equals to pi minus theta over WD. And WD has its own formula. Theta is equals to tan inverse of 1 minus zeta square that over zeta. And WD, this is the one we know, WN 1 minus zeta square. So for figure 1, we'll first find theta, which is equal to tan inverse of 1 minus 0.112 square over 0.112. It's just simply going to give us 1.458 rads. Then for WG, simply going to be WN in this case was 4.472 square root 1 minus 0.112 square. Going to give our answer as 4.44 rads per second. Putting it into the formula to be TR equals to pi minus 1.458 over 4.44, which is equals to 0.379 seconds. Now for figure 2, we do the same thing. You obtain theta, which in this case will be equals to 1.159 rad, and WD, put the same formula to be 4.10 rads per second. Then TR for this one will be equals to pi minus 1.159 over 4.10, which will give you 0.483 seconds. Now the next thing to calculate for is the peak time. Peak time, let's write as TP is equals to pi over WN square root 1 minus zeta square. So for the first figure, figure 1, equals to pi over 4.472 square root 1 minus zeta, in that case was 0.112 square, which will give you 0.707 seconds. And figure 2, simply put your values again to give you 0.766 seconds. So that's the answer for this. The next thing is settling time. So for settling time, let's put it as TS. It's going to simply be 4 over zeta WN. So for figure 1, it's going to be equals to 4 over 0.112 times WN is was 4.472, which is equals to 8 seconds. And for the second figure, simply substituting your values, you're going to get 2.236 seconds. Then for the last one, settling time. Settling time is evaluated as G as a function of 0. So in that case, you replace everywhere that you see S with 0. So this comes um 0 plus 0. So it's remaining 20 over 20, which is equals to 1. For figure 2, we evaluate as G equals 0. The transfer function here was 20 over S plus. So this is the transfer function here. So basically everything with S becomes 0. So it's 0 plus 0. which is equals to 1. So the settling time for this is 1 and the settling time for this is also 1. So thank you for listening. I hope you really understood. Settling time is CSS, by the way. Thank you for listening. Bye.